Okay, welcome. And today we're going to talk about center of mass when it relates to a thin plate called a lamina. Okay, so think about laminate or lamination. So a lamina is just a thin sheet of material. Okay, so we're going to now look at thin sheets of material within a plane, and so we're going to find the center of mass, and the center of mass of a lamina we call a centroid. Okay. Now also we're going to assume that this lamina is thin enough to be able to treat this in a two-dimensional scenario, and also we're going to assume that the density is uniform across the lamina. Okay, so again we're going to make that assumption that we have uniform density in the material. Now, there's a symmetry principle that's listed as a theorem, but I'm not gonna prove it, but I'm going to state it. It says that if a region R is symmetric about a line L, then the centroid of the region R must lie on that line L. Okay, that's the principle, the symmetry principle. Okay. So we're going to use that. In fact, just as a quick example, to kind of show that that is indeed the case, is let's assume our lamina is a rectangle. And so if we look at the symmetry of this thing, we know that on a rectangle, again, assuming uniform density, constant density, that we're going to be symmetric here, so the centroid is going to be located right there. Okay, or in other words, the way it's stated in the textbook and most is that it lies on the diagonals. Okay, but on a rectangle you could write it symmetry this way, a line of symmetry this way, and a line of symmetry this way. You can show that the centroid has to be on both of those lines. Or if you want, you could also show that it has to be on the diagonals. Okay, because by the same token, if you go on the diagonal of a rectangle, the diagonals also are lines of symmetry. Okay, so this just shows, this is an example, a very easy example to see how the centroid lies on the lines of symmetry. So now what we're going to do is in the next video we're going to start in a more general case of any type of lamina that has different shapes to it. Now also, because we're assuming a very thin lamina and constant density, the centroid is going to be based on the shape of the lamina, okay, and not necessarily the distribution of the density, how the mass is distributed. Okay. So we'll see you next time. We'll start deriving the formulas for finding the centroid of lamina.